So now let's see how to make predictions using the model we have built here. For that, I will use the predict function. Okay, so actually let me make this. Yes. So predict, and we are going to input the model name. So we save the model into this model 7. So let's take that. And then we are going to say, we are going to provide the data that we want to make a prediction on. In this case, it's the same data we used. So I will just give the same name, but you have to say that it's, it's a new data here. And actually it's the name of the data you provide there. Okay. If you run this, you can see it makes predictions. So how does it make predictions? Basically, the model is here, right? So when we look at the model, it's we have the winter rain as input, AGST, harvest rain, and age, and these are their corresponding coefficients. So basically, by looking at this data we provide, it will take the corresponding columns, and then it will multiply them with these coefficients here, and also subtract the intercept at the end, and that will be the prediction that you see here. Okay, so now let's save this into pred. And then the next thing I want to do is I want to create a small data frame where it has 2 columns. The first one is the price of the wine, right? So I want to save that, and let's call it column price. And the second column will be prediction. So I will say pred, and it will be this pred vector we just created here, which is a prediction. So if I look at this, you see there's only 2 columns. Okay. All right. So now what I want to do is I want to import this library called Yardstick. Library Yardstick. Now I have to confess I did have a lot of trouble installing this. It required me to update some other packages. Rlang was one of them. And while updating them, I did have trouble, so I had to really spend some time on it. So when that happens, one way could be to delete the Rlang library from the libraries where the from the location of where the R libraries are installed. If you delete that, reinstall it, it might help. If not, you might have some issue about DLL. And I did prepare a document for that, so I will try to share that with you as well. So let's get this in. So basically this library has different performance matrix in it. What do I mean by that? So basically I want to see how good this model is doing. You see there's some differences in the actual price and the predictions. I want to see how good we are. So the function that I'm going to use within the Yardstick library is called the metrics. Is a general function which will provide several metrics for us, performance metrics. The way it works is we need to provide the dataset name. So in this case it's df, and then you have to specify which column is for the truth, meaning the actual column. In this case it's the price column, and which one is the estimates. In this case it's the pred column. Okay, so if I run this one, you see gives some outputs here. So it says RMSE, standing for root mean squared error. It's 0.26. R squared value is 0.82, and you can see the 0.82 from here as well. From this model we could see the R squared value. Why is it giving the same? Because both the model was trained on the same data, and it was also, we used the same data set here to make predictions on. So we should expect to get the same R squared value. MAE is the mean absolute error, so that's 0.22. If you want to get some specific metric out, you can use, for example, RMSE directly, the function as well. So that will give the root mean squared error. The input is the same. So the dataset name, the truth, and the estimate columns. So you get the RMSE value like so. Okay. So what's the let me try something here. So if I save this into I don't know, let's call it matrix 7 for M7. Let's run this. So this is a small data frame, I suppose. And if that's the case, I can, for example, yeah, I can get this numeric value out from there. So this is the RMSE of this model. Okay, so what are we trying to do? Well, if you had several models like we did here, like we had created 7 models. So we can run the RMSE on them, and then we can choose the best model among those. The thing though is we trained on the same data set, and then we estimated on the same data set, right? That's not a very good practice. I mean, that's kind of cheating, if you will. Yes, it will give an overall idea of how the model is doing, but it's not the correct way to do it. So what we should do is we should actually have some other separate data set to work on, make predictions on, and assess the performance of our model on that unseen data. So I will feed in a new data set called the wine test data. It's a very small data set. Basically, some of the years were not included in the wine data, but they are included in the wine test data set. So this is the wine test data with 5 rows. Okay. So let's save this into wine test variable. I will make predictions on this dataset now. So, for example, what I could do is I can basically, just like we did here, remove predictions. Now I will say make prediction using the same model, but now the dataset is going to be wine test. Okay, so these are its predictions. Same way like before. Let's save it, and then I want to create a small data frame again. Copy paste from here. Okay. So this is wrong what I just did. So we are now working on wine test. So I'll get the wine test price and the prediction from here. Okay, let me rerun this. Okay, 5 rows. These are the actual prices, and these are the predictions. We are good. So what I just did here, I can just repeat now, right? I can look at the matrix of this model. So df red, okay. So the R-squared, for example, has decreased quite a bit there. Generally, that's expected, okay? The performance on the training set will always be better than the performance on the testing set because this data was not seen by the model. Although there's quite a bit of a decrease there, so that's not a very good thing. I mean, there will be a decrease, but that decrease shouldn't be that much. So let's also do this. Where is that? You know, what I'm trying to do is I'm trying to get the RMSE value. Okay. So if I scroll back up on what we did, so I have to rerun these things because I had closed my R. So for example, model 6. Right, model 6 was this, and also I'll just add one more value, one more model here. Model 5. Let me do one more, like model 4. Okay. All right. So now if I scroll down, what I did here. Okay. These numbers are not important. I'll just make them M I'll change the object name, the model name inside. Okay, so oh wait, I need to make predictions. So basically I'm going to make predictions using those models. And so I need this actually. I'll make predictions. Let's do that. So for example, using model 4, we're going to make predictions, and then I'm going to create a data frame. And then I'm going to use that data frame to get this value out. I don't need these things. Okay. So model 4, let's run it. So model 4 is 0.45. Okay. So let's save this. So I can call this RMSE4. So that's model 4. If I change this to model 5, make predictions, create a data frame, and then RMSE5, right? Model 6, make predictions, create a data frame, and then get the RMSE of that model, so the root mean squared error. Finally, model 7. And let's save this into model 7 RMSE as well. All right, perfect. So now if I started with 4, RMSE5, RMSE6, and RMSE7. This is the vector showing the different models RMSE values. And you can clearly see, by the way, RMSE is root mean squared error. So the smaller RMSE, the better the model is. Right, so 0.45, 0.33, 0.33, 0.28. So what are we doing now? We are basically trying to select the best model. So in this case, I would go with RMSE7. So that's model 7 because that one has the smallest error there. RMSE5 and 6, they are the same. Oh, they might be the same model actually, right? So that might be the case there. So yeah, so this is how you can create linear regression models, look at the R-squared value, make predictions, and then look at the performance of your model as well, and make comparisons, and then be able to select the best model among them. Thank you.